property. Closure property of addition is possible on whole numbers. Previously we have learnt. Commutative also is possible of commutative property of addition of whole numbers is possible. But now we have taken subtraction. Let us see is it possible or not. So closure property under subtraction. Take any two whole numbers. For example, 1 and 2. And let us do subtraction of these two whole numbers. So 1 minus 2. We are getting here 1 minus 2 is minus 1. So previously in addition we got whole number plus whole number. We got the same whole number. But in this case, whole number minus whole number, we did not get the whole number. So that's the reason the closure property of subtraction is not applicable for whole numbers. Let's see the commutative property. Commutative property we have learned for the addition. The same order will be applicable for subtraction also. Instead of addition, let us take subtraction. 1 minus 2, and let's change the order of it. 2 minus 1, and 1 minus 2 is minus 1, and 2 minus 1 is 1. So these both are not equal. Minus 1 is not equal to 1. So that's the reason. This is integer and whole number. This is integer. Here we got. And this is an integer. I is not equal to whole number. So these both are different. So what we understood is closure property of subtraction is not applicable for whole numbers. Let's see for associative property. 1, 2, 3, and 1, 2, 3, and we have taken a group of 1 and 2, and 2 and 3. So let us subtract this 2 and along with the 3 also. Minus, minus. Let us see if these both are equal or not. So 1 minus 2 is minus 1, and minus 3. 1 minus 2 minus 1 is minus 1. So 1 minus 1 minus 3 is minus 4. Minus of minus is plus 1. So 1 plus 1 is minus 4 and 2. So these both are not equal. So what we understood is this is an integer and this is a whole number. These both are not equal. So closure property of subtraction, closure property, associative property of subtraction of whole numbers is not possible because we got these different values here after substitution. Let us see identity of 0. 0 minus 2 is minus 2. So here we have subtracted 0. We have subtracted 0 from 2 or 2 from 0 we have taken, we get the positive value, but all the cases we need to get, that's the reason we have taken 0 first. 0 minus 2 is minus 2, it's not possible, that's the reason we don't have additive subtraction for this whole numbers. Properties of whole numbers, properties of multiplication. Let's see some of the properties here. Closure property, commutative property, associative property, and identity. Closure property after multiplication. Let's take some of the numbers. Take any two whole numbers. 1 and 2. Let us multiply these two whole numbers. 1 into 2, that is equals to 2. We have taken two whole numbers and multiplied the two whole numbers. We are getting the same whole number. So what we understood here is the closure property of multiplication of whole number is applicable. So let's see another example. 3 into 5 is equals to 15. So 3 is a whole number and 5 is a whole number and 15 is also a whole number. Closure property of multiplication of whole number is applicable. So let's go for commutative property. We have learned previously closure property, commutative property, that is 1 into 2, 2 into 1. So we need to exchange the values. change the order of the values 1 into 2 and 2 into 1. Let's see these two values are equal or not. 1 into 2 is 2 and 2 into 1 is also equal to 2. So this both values are equal. So what we understood here is closure property of multiplication of whole number is applicable. So let's take another example. 3 into 5 is equals to 5 into 3. So 3 into 5 is 15. 5 into 3 is 15. Next property is associative property. Take any three numbers. 1, 2, 3. 1, 2, 3. Let's take the group of 1 and 2. And here 2 and 3. Multiply this all the three numbers. 1 into 2 into 3. 1 into 2 into 3 in the bracket. Add 2 and 3 as a group. And here 1 and 2 as a group. So let us see these two values are equal or not. 1 into 1 into 2 is 2 into 3. And 2 into 3 is 6 into 1. So 2 into 3 is equals to 6. And 1 into 6 is 6. So 6 is equals to 6. What? And what we understood is associative property of multiplication on whole numbers is applicable. So let us take another example. 2 into 3 into 5 is equals to 2 into 3 into 5. So 2 into 3 is 6. 6 into 5. 6 into 5 is 30. So 2 into 3 into 5 is 50. 50 is 30. So what we understood? Associative property of multiplication of whole number is applicable. Let us see identity. We have learned additive identity previous class of associative of previous class, that is whole numbers of addition. So we take any whole number, add 0 to it, we'll get the same value. That is called identity of 0 under addition. Then here let us see this is multiplication. The same rule will be applicable. That is, let us take any whole number 5 multiplied with 1. So we'll be getting the same value. So take another example. 6. 6 is multiplied with 1. We'll get the value of 6. So we have taken a whole number and multiplied with 1 and we'll be getting the same answer. So the multiplicative identity is 1. So up to now we have discussed about properties of multiplication, of closure property, commutative property, associative property and identity of multiplication. Properties of whole numbers, properties of division. Let's see closure property of division. Take any two whole numbers, 1 and 2. Divide these two whole numbers. 1 divided by 2 is not a whole number. So what we understood is that we divide two whole numbers, we are not getting a whole number. Closure property of division on whole numbers is not applicable. So when we divide two whole numbers, we are not getting whole number. Closure property of division is not possible on whole numbers. Let's take the commutative property and commutative property. We take two numbers and we change their order. 1 divided by 2, 2 divided by 1. And let us see these two values are equal or not. 1 divided by 2 is a fraction. And 2 divided by 1 is 2. So what we can understand here, 1 by 2 is not equals to 2 by 1. So the closure property is not applicable of whole numbers on the division. Division of whole numbers is not applicable on whole numbers. take three numbers, 1, 2, 3, and 1, 2, 3. Here, let us take the root of 1 and 2, and 2 and 3. Divide this 2, and divide this 2. And also divide the first numbers. Here, let us see these both values are equal or not. 1 divided by 2 is a fraction, and divided by 3 is also will be getting a fraction. So 1 divided by 2 by 3. When we divide these two numbers, we are getting different values. That is 1 by 2, and this will be changed into multiplication. And 3 by 1 changes to 1 by 3. And this is 1. This is changed into multiplication. 2 by 3 changed into 3 by 2. And then after multiplication of these two values, 1 by 6, and here 3 by 2. And we know that 1 by 6 is not equal to 3 by 2. These both values are different. So what we understood, associative property is not possible under division of whole numbers. Property of 0. Let us see. We take any whole number divided by 0. It is not possible because 25 with 0 is continuously replicating, and there is no remainder. We will not be getting any remainder. 0. So continuously we can divide. So that is the reason it is not defined. So 2 by 0, it is undefined. So if we take the 0 value in the numerator and divide with any whole number, for example 0 and divided by 2, it's always will be getting 0 as a remainder. So 0 divided by 2 will be getting 0. So here what we understood is, if we take any whole number other than 0 and divide with 0, then that the value is undefined. And we take any whole number and divide with, and take any 0 and divide with any whole number other than 0, then we'll be getting answer of 0. So what we have discussed until now is closure property, commutative property, associative property, the property of 0,